useful for you for the later. Okay. Yeah. So then once the CPU simulator is open, you go through the tab, advanced tab, which is in the CPU part of this compiler. So this simulation tool, then click on compiler. And compiler is having three areas. One is compiler editor area where the high level programming language can be write. Then the compiler progress area. After writing the high level programming, you can execute the compile the program that will generate the instructions here. So let me quickly write the program back. Let me load the program which I already wrote to save the time. Let me load the program called the lab 3 experiment. Okay. So can you please quickly write this program test 1 on your simulation tool, please? Once you complete writing this program, please give your response in the chat box that it's done. The first line is program space test 1. Second is the declaration part. Yeah, Ramson, thank you. That's good. If majority of you complete, then we'll go to the next step. We still have 9 minutes time. Okay. Saving, good. Broxton, Audible Leon, RJ, Siraj. Okay, good. So then the next step is once this program is written here, the next step is you're going to compile the program. So click on the compiler part here, which is the down left corner of the window here. So then don't go for running it. Just click on compile the program. So first click on the compile the program. If there are no bugs here, your compiler generates the instruction that we call the assembly code. That code generation is completed here. So in the code generation, it's generated the CPU instructions. And for CPU instructions, the logical address is given. Okay, so can you please quickly tell me how many instructions are there? Can you count and tell me? How many instructions are there? If you compile your program on your CPU simulator, you can just quickly count and tell me how many instructions are there. Cameron 16, Louis 16. Total number of instruction, I'm just asking, count all the instruction right from memory address 0 to the memory address 0122. Jose Ramson, correct. 23 is the correct answer. So how do you know that? You can count these or you can click on this show button in the binary code form. So then here you can check it out by clicking on the show instruction statistics. You find there are 8 move. The move instruction that is counted 8 times in the program in the CPU instruction sequence. Then add instruction that is counted 4 times. Is it? That is here. The add instruction is here 1, 2, 3, and 4 times. And move instructions, if you start counting, 1, 2, 3, 4, 5, 6, 7, 8 times. Okay, it gives the summary. So here then the load byte that is counted twice. So total it gives the 23. Total 23. Correct? And then in your answer, in the assignment, it is asked that the total number of instruction, that is instruction count, and the next one is once it is compiled, if you click on show symbol table, whatever the entry that you are having, that type, size, and address, that you have to enter as an address, that symbol table content. Okay, and you must give your reflection that in the address, is the same address is used multiple times. So what is happening here? The third and fourth, there is a address overwriting. You have to give your reflection that why the address overriding is done. The address overriding for string 1. Okay. So the next is you need to load this instruction into the memory. So load in the memory. So that is loaded inside the memory. Okay. So when it is loaded inside the memory, then you can run the program by step. So in this observation, can you please tell me, oh, Ramchandra guys, okay, where the tokens are? That's good. Okay, good question. Go to the compiler and go to the compiler progress report. Once everything is okay, the first phase of your compiler is lexical analyzer. So here you can find how many tokens are there. How many tokens are there here? Yeah. So total 37 tokens. Is that clear? Is that making sense now? You know how the CPU simulator that we are going to enjoy. Are you getting the point or steps for analyzing? Good. Okay. So the next step, once you run here, once you are in the running program, check that before running the program, what is the program counter content? That is the address. That is 0. The first instruction logical address is there. Then what is the entry in the instruction register means? Nothing is there. If you click on the step first, when executed, the program counter address is changed in the instruction register. Which instruction is there means the first instruction is fetched from the memory and loaded into the instruction register. That instruction is move the value 6 into R2. The next, what is the result of general purpose register means the value 6 is in R2 register. Right? So this is how you're going to run. So like that, once you run all these programs completely, okay, at a fast rate for just quickly giving, okay, you found the total number of instructions here. If you click or go to this area, the CPU area, click on show pipeline, and here you can see the instruction count, CPU instruction count. So that is the summation of ICI, which we use, right? The classical performance equation is used to count this number of instructions. The clock cycles, it gives cycles per instruction, the average cycles per instruction, and the speed of the AMDA/speed of here. Okay, so by going through this, you will get all the answers which are used in the rubric.